Okay, in this video, I'm going to go through some problems that are intended to be able to find the empirical formula. So I'm going to skip to this one first. We have a 60-gram sample of tetraethylene gasoline additive. It is found to have 38.43 grams of lead, 17.83 grams of carbon, and 3.74 grams of hydrogen. Find its empirical formula. So first thing I'm going to do is I have got to set all of these grams into moles. So I'm going to go 38.43 grams of lead divided by its molar mass, which is, let's see, 207.2 grams per mole as a molar mass. That will give me a total of 0.1855 moles of lead. Okay, I'm going to do the same thing for the carbon. I've got 17.83 grams of carbon. I'm going to divide that by its molar mass, which is 12.01, and that gives me, that's grams per mole of carbon. That gives me 1.485 moles of carbon. Finally, I will do the 3.74 grams of hydrogen, divide by its molar mass, which is 1.01 grams per mole, and I will get 3.78 moles of hydrogen. Okay, from there, we have to divide all of the moles by the lowest factor of the mole. So I have 0.1855 moles of lead, 1.485 moles of carbon, 3.78 moles of hydrogen. The moles of lead is my smallest factor of all those. So I'll divide everything by 0.1855. Okay, that gives me 1 mole here, because 0.1855 divided by 0.1855 is 1. This will give me approximately 8 moles of C and approximately 20 moles of hydrogen. So if I were to write this empirical formula for this problem, I'm running out of space, but it will be H20 PbC8 as my answer. So this would be the empirical formula for this additive. Okay, I'm going to do one more problem right here. This time, I'm given a percentage, which is okay. For this problem, I'm going to assume that the percentages are the amounts in grams. So instead of a percent, I'm making that assumption that it's 63.52 grams of iron and 36.48 grams of sulfur. By making that assumption, I can now solve for this. So I got to do the same thing. I'm going to divide by the molar mass of iron, which is 55.85 grams per mole. And that gives me a total moles of 1.137 moles of iron. And I'm going to divide by the sulfur molar mass, which is 32.06 grams per mole. And that gives me 1.138 moles of sulfur. I then divide by the lowest factor of all those moles, which is just 1.137. That's approximately, well, this is 1 mole, and this is approximately 1 mole. So this empirical formula would just be F ES. Okay. And that's how you would solve it if we had percentages instead of grams. So we saw one with grams, and we saw one with percent.